Hello everyone, now in this particular session we'll be discussing about some concepts of solid state chemistry. So here we go, where the first one is about axis of symmetry. Now my dear friends, what is axis of symmetry? In simple words, it is an imaginary line drawn through the crystal about which, if the crystal is rotated through 360 degree, it gives the same appearance more than once during the course of the revolution. This is, my dear friends, the definition of axis of symmetry. Once again I repeat what it is. It is an imaginary line through the crystal about which, if the crystal is rotated through an angle of what? 360 degree, then it will show, or it will give the same appearance more than once, okay, during the course of revolution. So that means if the same appearance repeats after the rotation through 180 degree, then I call it as a twofold axis of symmetry. If I rotate it through 120 degree, I call it as a threefold axis of symmetry. What we need to do is, we have to divide this angle of rotation through 360 degree, because 360 degree is a complete revolution. So 360 divided by 180, you get 2. 360 divided by 120, you get 3. So if the repetition is after 90 degree, so 360 divided by 90, obviously you get the answer is fourfold axis. Okay, and finally, if suppose I get the same repetition after rotation through 60 degree, I will be getting a sixfold axis. Okay, so this is, my dear friends, about axis of symmetry. So I hope you have understood this very well. My dear friends, we move on to the next term, and that is about center of symmetry. Center of symmetry is a point within the crystal such that any line drawn through it will intersect the surfaces of the crystal at equal distances in both the directions. So my dear friends, it is a unique point in that particular crystal. So if I'm going to show a cube like this, this is a cube, and I show a point over here. So this is the center of symmetry. So that any line which I'm going to draw through that, okay, this way, this way, this way, okay, it is going to intersect the surface of the crystal at equal distances in both the directions. Right? That is what is center of symmetry is. So if I want to find out the total elements of symmetry for a cubic crystal, total elements of symmetry for a cubic crystal, I give you a simple example, and that is, say, NaCl. Then how much I will be having is, first is I will be having a diagonal plane, and that's going to be 6. Next is I have a rectangular plane that I have is 3. Next thing is I have a two-fold axis, that's going to be 6. then I'll be having three-fold axis, that will be 4. I'll be having four-fold axis, and that's going to be 3. And then center of symmetry, of course, it is exclusive, so it has to be what? 1. So now if you add all these, 6 plus 3 is 9, plus 6 is 15, and plus 4 is 19, and 3 is 22, and 1 is 23. So that means total for a cubic crystal, the elements of symmetry comes out to be how much? 23. So one of the best example is NaCl. Alright, so I hope you have understood this very well.